Hello everyone. Hope everyone's safe and healthy during this special and hard time. I'm Xianyao Chen from Ocean University of China. It's my pleasure to give a brief introduction of the joint research project supported by the Belmont Forum, the Arctic Fog Variability. Our research team includes William Peer from Bedford Institute of Oceanography, KK Tong from University of Washington, David from the University of Victoria, and Oxner from the Institute of Atmospheric Science and Climate, Italy. The rapid increase in open water surface area in the Arctic, resulting from the sea ice melting during the summer, may lead to an increase in fog. It poses scientific and operational challenges. The project of Arctic Fog Variability is trying to study the following three questions. How does fog vary on different timescales? And what's the main dynamical processes of fog sea ice feedback? And how will change in Arctic fog affect the potential trans-Arctic shipping routes? We have to see that we didn't finish all of them so far. The only reason is that we don't have enough data. Therefore, our first step is to observe, to collect, and reconstruct fog variability in Arctic. We do that based on the following three methods. First is to collect all of the historical visibility observations from the land stations and shipping lines. This figure shows the records from stations which have more than 40-year observations. We can see the obvious seasonal variability and some interannual and interdecadal variabilities. But unfortunately, most of the stations have no such long records and they are not quite continuous. Our second step is to develop an instrument to capture the vertical radiation profile in the fog. We have collected many profiles during the cruises in Arctic and also in the Yellow River stations in Arctic. Here's two examples of the profiles. We could see the spatial variability in the surface boundary layers during the fog event. We are working on this. The third step is to reconstruct the Arctic fog variability from the satellite images. We developed a fog detection algorithm called the partial T, using the temperature difference between the cloud top and the surface. Based on this method, we have reconstructed a fog time series over Arctic from 2003 to now. From this dataset, we can study the frequency and patterns of fog in the Arctic. We are using it as an observation to compare with our model output. The second main output of AFV project is to improve the Arctic fog simulation. Here we mainly focus on the summer fog, not ice fog, because the ice fog has no potential impact on the shipping activities. We compared some parameterization schemes to simulate fog using Polar WRE. The detail is given in this paper. And this is an example to use the Polar WRE to simulate fog with our improved parameterizations. Polar WRE confers the real sea ice fraction. The sea ice fraction influences the formation and the development of sea fog. Therefore, it can track the variations in the relative humidity of observations very well. With Polar WRE model and improved parameterizations, we compared the simulated Arctic fog with 40-year observations. It seems that Arctic fog has no strong trend in the past 40 years compared with the climate internal variability. However, when we look forward, a significant change in future when sea ice strongly decline. To study this issue, we use the RCP 8.5 scenario by the CCSM4 model as a boundary condition to force the Polar WRE and find a strong and significant change in fog frequency in 21st century. Summary: we construct a time series of Arctic fog variability, forming the database for the future research. And we improved the Arctic summer fog simulation and found no significant trend during the last 40 years. But our results show that the Arctic fog is much likely to increase in the future and arises risks in the shipping routes. Thank you for your attention.